started on depth of sense on Friday, and I remember very well that I told you guys that we are going to start the slide again because time kind of ran out. So I'm still going to start the new section again. Okay, it's still module 5, but the last section of module 5. Okay. I don't think we did any questions. So I'm just waiting for my I'm waiting for my PowerPoint to load up. It's also taking time as well. It's almost like everything is conspiring against me today. Can't even see anyone now. I don't know what happened today. My team is acting up badly. I apologize for that. I still don't know why it's doing that. So just give me a few minutes, guys. Just about 3 to 5 minutes. I'm just trying to get my PowerPoint slide up and running. Okay, should be coming up just now. I'm still waiting, guys, for my PowerPoint. Again, I apologize. My network is quite slow.
So you can hear me. Yeah.
Yes, there's a hand up. Finally, Musa, I can ask might as well we do some question session if you're waiting for my PowerPoint. What's your question, Fanny?
Can you hear me?
Yeah, I can hear you.
There's a question that I'd like us to do. It's can I actually say it because I'm not sure how I'll give it to you right now for you to see.
Yeah, what you can do is maybe you can tell me. I can try and you can tell me which is it? Is it a past question paper?
Yeah.
Which year is it?
2012 November.
Okay, let me look for that. Maybe that might come up faster than my PowerPoint.
All right.
Sir?
Let me just. Yes. Who's that?
Utwano. Sir?
Yes, I can hear you.
For test 1 on the question and memo, are we only going to answer from question 1 till 3 for the national test?
Yes. Thanks for that question. You see, I was talking to one of the students, and she was saying that a lecturer was saying it's module 1 to 5. So I was explaining that you see, if you look at the PACER, it has weeks. Now, some textbooks also follow the PACER as well. But when I talk modules, I talk of what's in the syllabus. Now, the syllabus has module 1 to 3, but it can, like module 2 can be divided into 2 weeks. Module 3 can be divided into 2 weeks. So you discover that the test is covering week 1 to 5, but on the module, on the syllabus, it's module 1 to 3. So what I like to do is to give students the topics. So the topics that are coming are, topic 1 is differentiation, which is module 1. And then topic 2 is integration. And then topic 3 is partial fractions. Now it is, as I told that, it might be 5 weeks, but it's 3 modules. But if you look at the pacer says week 1 to week 5. I don't know if that makes sense.
Sorry, sir. I've been looking at a few past papers, and there's also a general solution in it. Is that a part of partial fractions?
General solution. No, general solution is for module 4, which is differential equations.
Okay, thank you so much, sir.
Yeah, so if you look at that, it's module 4.
So basically what you're saying is that because of the question paper has like 6 questions, so we can
Yes.
practice for question 3 for test 1.
Yes, exactly. That's what I'm saying. So you can
Okay.
just practice up to question 3.
Okay.
Okay. Let me try and look for the past paper, right? Because honestly, this thing. Okay, I think I'm now back online. I'm still going to do. I'm going to try and finish this, then still do the question that what's the name? Fanel asked me. Okay. You said in November, which 2000, which year and which paper exactly?
It's no, I only got like 1 page of it's literally question 1 and question 2. I don't have the front
No, it's
page.
okay. No, it's
So
okay.
it's November 2012.
Okay, I will look it up. Okay. My PowerPoint is coming up, but I'm still going to look it up as well, and we can do it together, if not today, on Friday.
Okay, sure. Thanks.
Okay, I think my PowerPoint is up and ready. I hope. I even opened the wrong PowerPoint because of all this delay. Open the one for Moment of Inertia, which we've already done. So I need to go away from that. And go back to week 12. Okay, I'm trying to find out where I can quickly get the past papers. Okay, guys, finally we are here. I can share my PowerPoint. Okay, saying open in PowerPoint, so let's just wait for it to open up. Can you see my PowerPoint? Or not yet?
Yes, sir.
You can see it.
Yes, sir.
Yes.
Now, if you look at it, this is what we said last on Friday. Okay, I was explaining depth of center, and I said it's second moment divide first moment. Okay, and then I said, I don't know why it's still coming so small. It should be full page to me. I need to be full page. Okay, full screen. I got it now. So, and we said y is the distance from the x-axis to the representative strip, and r is the distance from the water level to the representative strip. And then we said dA is equals to 2x dy. And then from there, I explained to you that the shapes that we use is the trapezium, parabola, rectangular, triangle, and semicircle. Right. After that, I say that I gave you the shape. So this is a trapezium. Okay, it's supposed to be a complete one. I don't know why it's not complete. It's supposed to be all the way there. Let me just need to stop sharing because it's not as big as I want it to be for some funny reason. Okay, good. So there's trapezium, parabola, rectangle, triangle. And then we went to example number 1. Okay, so all this we did last week on Friday. Okay, I said a vertical plate in the shape of a trapezium is installed in a demo. The top of the plate 10 meters wide and lies 1 meter below the water level. Okay, and then they give us all the information. We got this down from last week. And then we need to calculate the relation between x and y, and then the second, and also calculate the area moment. They need to calculate the second moment of area. Okay. Now, this is what I said you should look at. Look at the keywords in the question. So the keywords, number 1, the shape. Then after the shape, number 2 are the dimensions. You look at the top, it's 10 meters, and it's also 1 meter below the water level. The bottom is 8 meters, and the height is 3 meters. Okay, so those are the details. They're actually shown in red. Okay, so from there, we went on to start to do the sketch. So remember, first thing they told us is that the bottom is 8 meters wide. So what happens is our shape, it is bisected by the y-axis. What do I mean? Like the y-axis, it cuts it in half. So if it's 8 meters, it starts from -4 to 4. Okay, so you need to understand that part. The shape is cut in half by the y-axis. So if it's 8 meters, it means it starts from -4 to 4. And then, like, there you go. It starts from -4 to 4. And then if it's 10 meters, the top, it starts from -5 to 5. Okay. And next, you complete the trapezium. So this is my trapezium. Now look at it this way. If you look at the bottom part, the x values is -4 to 4, but the y values are 0. Why are they 0? It's because it's on the x-axis. On the x-axis, y is 0. Okay, so if you look at the bottom part, it's -4 to 4, the x values. but the y values are 0. Okay, if you look at the top, I only put the x values minus 5 to 5. Now, they told me the height is 3 meters. So it means this shape is like that high. So it means my y coordinates is going to be what? 3. You see that? Because it's 3 meters high, so my y coordinate is going to be 3, which means my points is minus 5 and 3 and 5 and 3. So that's how you look at it when you do a trapezium. Now remember, they told us that the top part is 1 meter below the water level. What does it mean? It means the water level is on top. Okay, so that's the water level there, and it's 1 meter. 1 meter, top of the way is 1 meter below the water level. Somebody was asking last week on Friday to say, can this water level be below the top? It can't. The water level is always on top of the way. Or if it's not on top, it's on the same level. Okay, so that's how it is like. So now the total is 1 meter below. You can see that there's my 1 meter below there. So it means my water level is on 4. I'm going to stop here for a while and see if there's any questions just on that first part. Or maybe I'll wait for questions when I'm done, right? With example 1. Someone's mic is on. I don't know whose mic is on, but okay, let me mute everyone. Okay, there you go. So next, you see this, I've drawn the representative strip. Okay, it is in the y-axis, my representative strip. Okay, and then after that, the distance from the x-axis to my representative strip, it's y. Okay, remember I showed you that at the beginning of the slide. I showed you 2 things. I explained what is my r and what is my y. Y is the distance from the x-axis to the representative strip. And then to calculate my r, it's 4 minus y. It's basically the distance from the water level to my representative strip. Okay, and it will be 4 minus y. Because you can see that, let me draw it. This distance is 4. Ooh, okay, that didn't go well. Let me try and draw it more nicely. This distance is 4. Okay, this is 4 meters, and this distance here is y meters. This is y. So it means the remaining distance from the water level to my strip is 4 minus y. So I hope you understand. Now maybe someone can ask, how do I know where to put the y? You can put it anywhere as long as it's inside trapezium. Okay. Me, I just put it at the center, but it's not necessarily the center. It's anywhere there. It's what do you call it? It's anywhere. Just know that you can put it anywhere there, as long as it's inside. Usually people put it at the center, but you can put it at the bottom, at the top. See, because it's y, we don't know exactly what it is. That's why we're actually calculating that distance. So we call it y. Okay. So this is where we are so far. Now next, after we've done this, I now know what is my r. Okay, that's the important thing. Next, I need to find my equation for the, you see this straight line here. See, because this, you see, this is the area we're going to be calculating, delta A. Now, if you remember, at the beginning also, I said delta A is equals to 2x delta y. These I said at the beginning. Now, a normal area in the y-axis, it doesn't have a 2. It's just delta A is x delta y, which is what I shaded here. But see, there's two parts. It has to be this. I'm applying by 2 because I'm also including this area here. Let me use a different color for that. I'm also going to include this area here. That's why there's a 2 there. So we only calculate the first part in red, then we multiply by 2. Okay. Now for us to calculate this area in red, we need the equation of this straight line here. Let me use a different color for that straight line. I'll use purple. We need equation of this straight line here. This is like our graph. You see that straight line? It's like our graph. So I need to know the equation of that graph so that I can find my formula for dA. I'm not going to calculate the area, but I'm just going to find my formula for dA. So I hope you took note of those things. If you have any questions, please just write them down so that you can ask. Okay. Now, next. Like this is what I told you the formula is, right? Just a reminder of the formula I told you, right? So now, the first moment of area, that is our formula, R dA. So I need to remember, I now know what is my R. I told you our R is 4 minus y from that graph that I showed you. So only thing I need to find is my dA. Okay, so my R is 4 minus y. Okay, so what I need to calculate is my dA. We know dA is 2x dy. So I need to find this x. Is that okay? I need to find that dx. So how do you find that x? How to calculate that x there? We go back to our graph. I hope this slide is not too fast. Is it too fast by any chance? Is it too fast or it's okay? Sorry, I have to ask.
It is okay, sir.
Oh, thanks. So what you need to do is to calculate the equation of this straight line. You see, I put it in black. Remember, last time I showed you in purple. So now it's in black. So we need to find the equation of that straight line. Now, how do you find the equation of a straight line? You find the gradient first. Then after the gradient, you use that to find your equation. You see? So you find the gradient first, and then you use this one here. Now, some people can use a different way of finding the equation. I don't mind. There are different ways to find an equation. But the important thing is you get the correct answer. So when you get your equation, it is in terms of y. Do we see that? But remember, I want x. I want in terms of x, not in terms of y. So what do? I make x the subject of formula. Now, from here, you guys have looked at it, right? From here, what we do next is we now know what is our x. So here, where there's dA, I'm putting my x here. Remember here, I'm removing this x and I'm putting this equation here. Is that okay? So what does it mean? It means I now have I can now calculate my first moment of area. Because I now have my R and I now have my dA. Now, where do I get my limits? I will need limits. The limit, it will be 0 to 3. Okay, the limit is where your shape starts and finishes. Like my trapezium, it starts at 0 and ends at 3. Important thing, your limits are in the y-axis. Okay, your limits are in the y-axis. So they start from 0 to 3. So number one important thing to note is that your limits are in the y-axis. That's first important thing to note. The second thing is you don't go up to the water level. No, it's only the bottom and the top. So it's 0 to 3. Okay, so let's go ahead, right? And see how we're going to calculate first moment. So this is what we do now. You see, where there is R, this is what I put. This is my R here. And then dA, I put all this. This is my dA. Do you see that? So I now have my R times my dA. And you can see my limit is 0 to 3, like what I told you before. So from here, we simplify. I can take out 2/3. It's a constant. I take it out. So I remain with 4 minus y times y plus 12 with respect to y. Now, from here, guys, you should know it's straightforward integration. How do we integrate this? You're just going to expand. These are two factors. You just expand them. After you expand them, you integrate, you put your limits, and then you get your answer. Okay, so I'm just going to leave this for just a few seconds so that you guys can look at it, and then I'll show you the integration part. Okay. I can even start to show you here so that as you're looking at it before I move to the next page. But this is also coming up in the next page. So here 4 times y is 4y, minus y times 12 is minus 12y. So 4 minus, in fact, it will be minus y squared. You guys know how to expand. I won't even show you how to expand. I'll just show you the answer. So it's minus y squared minus 8y. Minus 8y plus 48. So we are integrating all this with respect to y. Okay, obviously you have to apologize for my handwriting because you know what, I'm trying to use my mouse, is tricky. So this is what you do, and then you're going to integrate this. Okay, so I'm just going to go to the next page to show you all this. As I always tell you guys, I'm always careful about trying to not rush my slides. Okay, so I'm sure you guys have seen it, right? Next page shows us this. So you'd have integrated, sorry, you'd have expanded, and then you integrate, and then you substitute, and then you get your answer. So this is how we find first moment of area. Okay, so That's how you do it. Okay, we're going to go to second moment of area, and then we'll get the final answer. And then if there's any questions or you want me to go back to any slide, you can tell me. Right. Now, second moment of area, it goes like this. So it's same as first moment, but the difference is our R is squared. So if R squared, and we know R is 4 minus Y. Okay. But besides that, the working is all the same. Only that second moment was R squared. So we put our R is 4 minus Y, which is squared. Our dA, we know is 2/3 Y plus 12 dy. Okay. So this is what we do. And we know that from here, we're going to expand. We expand, it's a bit long, because you have 4 minus Y times 4 minus Y. You expand that, then when you expand it, you have to multiply with Y plus 12. So it's a bit long. Okay, but you just have to do it, and obviously you have to be careful not to make any mistakes. So when you expand the first 4 minus Y squared, that's what you get, 16 minus 8Y plus Y squared. Okay, I always feel that I'm rushing a bit too much, so I'm trying to slow down. So when you expand, this is what you get. From there, you multiply with that and you get this. This is supposed to be in brackets. My apologies, that is not in brackets. Supposed to be this, supposed to be in bracket like this. Okay, and then you integrate. Sorry. So just look at it, guys. The second part. So just remember, second moment is same as first moment. So if you understand first moment, you understand second moment. The only difference is first moment it only has R, but second moment it is R squared. But the whole working is the same. Okay, so just look at it, guys, for just a couple of seconds before I show you the final answer of second moment. Okay, guys, so from there, we'll finish up and we get that answer for second moment of area. Okay, so you see the answer is 181.5. What you should do is, like what I always tell you to do, try it by yourself, right? So that after you finish this lesson, I know you've gotten down the question, right? You try it by yourself and see if you get the same answers. Okay. And then from there, now depth of center is second moment divide first moment, and then that's our answer there. Okay, any questions on example 1? Anything you're not sure about? Yes.
Morning, sir. So I just got some problems to go to my Demle, so I came here to Demle on physical one to solve my problems. I just came now, and I just find out, and the things got. But I don't have an IFA at time to continue the class, so I have to go home. So that's why
No,
I'm gonna
no,
be
it's
late.
okay. No, it's okay. I understand. Thanks so much for letting me know,
Okay, no
Autiano.
problems.
Okay. Any questions? Anyone's got any questions on example 1? If there are no questions, then I can. Maybe you're still trying to understand it. Maybe example 2 will be better for you to get it. Okay, so no questions, right? Can I go to example 2? Can I go to example 2?
Yes, sir.
Okay, let's go to example 2, right? So this is example 2. This is the first part, 2.1. It says a vertical sluice gate in the form of a parabola is installed in a dam wall. The top of the gate is 7 meters wide and lies 2 meters below the water level. The height is 4 meters. Draw a sketch of the plate and show the representative strip that we use to calculate the first moment of area and the second moment of area. Calculate the relationship between the variables. So this is 2.1. Okay. The first part, 2.1, is asking us, is telling us that it's a gate in the form of a parabola. They tell us the top is 7 meters wide and is 2 meters below the water level. And then the height is 4 meters. So we're given information. So they want us to do the sketch and the strip as well as to calculate the relationship. Okay. So there's also question 2.2, obviously. 2.2 should be asking you to calculate the first moment of area or something like that. Okay. 2.2, calculate the first moment of area. 2.3, calculate the second moment as well as the depth. Okay, so I'm just going back to 2.1, but 2.2, we're calculating first moment of area. 2.3, second moment. Now, I might as well give you something to take note, right? Sometimes they'll ask you to do the sketch and all the like, right? And then they can say, calculate the second moment and then calculate the depth given the first moment. They can give you the first moment. Or sometimes they give you the answer for the first moment, they want you to calculate the second moment. Or sometimes they give you the second moment, they want you to calculate the first. So if they give you information to say the first moment of area is this, calculate the second moment. You don't have to calculate the first moment if they give you. Okay, I've seen some students do that. Please don't. If you do that, you're just wasting your time because it's already given. They won't even mark it. Okay, so it's not all the time, just a few times they can ask you that. So take note of that. Okay, so this example 2 is a parabola, right? And we need to sketch it and do first moment and second moment. Okay, we're ready, guys. I'm sure we're ready. Let's go. Let's have a go at it. First thing is, it's a parabola. So this is what it is like. Okay, might not be very smooth. You know, like I'm using a mouse to draw it. Okay, I expect yours to be a bit smooth. You know, a parabola, it's like a nice smooth shape. Okay, and top is flat like that. So from here, the information they give us, we're going to plot it. Okay, I'm excited about this to explain to you guys. The first thing is, it's at 4. Why is it at 4? Because they told us our height is 4 meters. So I know that the bottom is at 0 and the top is at 4 because the height is 4 meters. Okay, that's the first part. Second part, they told us that it's 7 meters. This is 7 meters. the top is 7 meters wide. This is 7 meters here. So if it's 7 meters, it means this is 7 over 2 and this is minus 7 over 2. Do you see that? You divide 7 by 2. So the left side is x is minus 7 over 2. The right side is 7 over 2. I hope that makes sense. You saw when you're doing the trapezium, we did the same thing as well. Okay. Our height is 4 meters, and then our width is 7 meters, so we divide by 2. So it starts from minus 7 over 2 to positive 7 over 2. Okay, and then the next part is the water level. It says 2 meters below the water level. So the water level is at 6. Okay, so I hope you're understanding that step by step. From the information given, they gave me the height, they gave me the width, and then they gave me how many meters it is below the water level. I'm hoping that example number 3, it's the water level is on the, because sometimes I told you last week, the water level can be where your top is there. Okay, sometimes it's like that. So from here, my y, I put this is my representative strip here. Okay, I ticked it. So I know the distance from the x-axis to the representative strip is y. Therefore, my r will be 6 minus y. From the water level to my strip, 6 minus y. Where does the 6 come from? Remember, I told you that from here to here, this is 6. This distance is 6. Okay, so it means this r will be 6 minus y. Now, I hope no one is going to ask me where did I get this 6, because I just explained to you, but I don't mind going back. I'm just thinking in my mind that someone might be asking, where did the 6 come from? What we do, we know that the height is 4 meters, and they told us that the top is 2 meters below the water level. So if the top is 2 meters below the water level, and the top is at 4, it means the water level is at 6. Because it's 2 meters, so you add 2 to 4 to get 6. Okay, so I just thought, let me explain that again, where the 6 came from, in case maybe someone could have missed that part. And then from there, we get our y and our r, which is 6 minus y. Yes, question.
Hello, sir.
Yes.
Can I ask, sir, are we always calculating in terms of dy strip, or there's a time where we'll have to calculate in terms of dx strip?
Very good question. Thank you so much, Richard. Okay, Richard is asking that, are we always calculating in terms of dy, or is there a time we're going to use dx? That's a very good question. Thank you again. We always calculate in terms of dy. Okay, you see, what we are looking for is how deep, it's like how deep is the center of gravity. It's almost like center of gravity. Okay, like any shape that you have, you can calculate center of gravity from the bottom. Okay, even a human being, we all have our center of gravity. If it's a car, any shape, I think in Science N4, whoever did engineering Science N4, there's a topic under statics where you calculate center of gravity and centroid. So it's important to know where the center of gravity is. So center of gravity is measured from the bottom going up. That's why we always use dy. We never use dx. Okay, so thanks so much for that question. So yes, we only use dy, we never use dx. It's only with respect to y. Okay, that was a good question, Richard, thank you. So from here now, guys, from here what we do, let me use a different color. Remember, we are going to, I need another color. Let me use color is this? Blue. So we need to count. This is my DA, this area here, or this area here. Okay, I'm only interested in this first part, the area in blue. Okay, so I'm like wanting to calculate this area. This is my lower limit, 0. My upper limit is 4. I'm calculating this area in the y-axis. Okay, I'm looking for my DA. I'm not calculating area. I'm just looking for my DA. Okay, with respect to the y-axis. So we know that DA is going to be 2x dy. So I need to find that x part. How do I find the x part? I need to find the equation of this part of equation of this. Now this is a parabola. So I need to look for equation of my parabola. In other words, I just need to know what is the equation of my parabola. Is that okay? So when you're doing the trapezium, it was a straight line with trapezium. But with parabola, it's not, it's a parabola. So relationship between the variables, we need to know equation. This is the equation of a parabola. Y is equal to ax squared. Now, somebody might ask, why am I using a short version? You know, because many people, they know equation as follows of a parabola. The long version is y is equals to ax squared. Yeah, I need to invest in a touch screen. You know, this thing would be nicer if it has a touch screen. Ax squared plus bx plus c. Okay, I think I did that well. So this is the equation of a parabola. So why am I using the short version? Can somebody try and maybe guess? Let's go back to them. Okay, I need to remove all these drawings. So if you're looking at this graph, why am I using the short version? Y is equal to ax squared and not the full version? Just need someone to try it out.
Sir,
Yes.
isn't it because you're calculating half of the parabola, not the whole parabola?
Not as such. Even if it's half a parabola, the equation will be the same. So it's not really that, but it's close enough. That's close enough.
So
yes.
is it not? So
yes,
is it not
try?
because you're going through 0?
Is it not?
Because you're going through 0.
Yes, that's it. Thanks so much, Niso. Sabelo, that was a nice try as well, right? Thanks. It's because it's cutting on the origin here at 0. Okay, so the general graph, a parabola that cuts on the origin like this, if it cuts on the origin like this and goes back, it's got that equation there. We don't use the full one. But if it's another one which cuts twice like this, we use the full one. But one that cuts on the origin only, that one, you use that one. So that's the reason why. Okay. So let's move on, right? So this is my equation of the parabola. So if you look at this, only thing I need to find is my A. I don't know what is my A. I can't use an A there. I need a full equation. So how do I calculate A? I'm going to put this point into my equation to find A. We know that this point is on the parabola, right? We know that 7 over 2 and 4. So x, where there's x, I put 7 over 2. Where there's y, I put 4. Then if I solve, I get my A is 16 over 49. Okay, so I've calculated my A. It means this is my equation for y. Y is 16 over 49 x squared. How did I do it? Just to say it again. I know my general equation, y is equal to x squared. But I know that on the graph, if I can sketch The graph is like that. There's a point here on the graph which is 7 over 2, x is 7 over 2, and y is 4. So for me to find the value of a, I can take any point on the graph and put it in my equation. So I took this point there. We actually have 3 points, eh? The one with 7 over 2 and 4, another one in minus 7 over 2 and 4, and the third point is the origin 0 and 0. Now you can't take the third point, it don't give you a value for a. So you use the other 2 points. So I took this one here. You can take the one with the minus 7 over 2, it will still give you the same answer.
Okay, sir. Sorry, sir.
Yes, Bunguke, you can ask.
Can I see the slide of the question?
Oh, okay, let's go back to the graph so that I can show you the graph.
I just want to take a short screen.
The question, not this.
The question and this.
Okay, let me go. Okay, there's the question then. So take a peek.
Okay, and the other one.
This one, yeah?
Yeah.
Then, okay, let me put the final one, right? Okay, this is the final one here that you need.
Yeah. Thank you, sir.
Okay. Okay. So, guys, we've explained how you find the equation. So this is the equation, y is 16 over 49x squared. But remember, I want it in terms of x, not y. So I have to make x the subject of formula. If you make x subject of formula, this is what you get. Okay.
Sorry, sir.
Yes.
So how if we use this other formula of parabola, we can't have the same answer?
You see, if you use the other formula, which is y is equal to ax squared plus bx plus c, automatically b and c are 0. So that's why we don't use that other one.
Ah, okay.
Yeah, because I was explaining that this graph, if you look at the graph, it cuts on the origin here. You can see it only cuts on the origin. So because of that, your values for b and c will be 0. So we only deal with y is equal to ax squared. We're only interested in calculating a.
All right.
Okay. Sorry guys, we're going to extend. We're going to extend the lesson a bit, right? Because it started a bit late. So apologies for that. Maybe by about 10 minutes or so. So if you look here. If you look here, I got my equation, which is y is 16 over 49x squared. And I made x the subject of formula. From there, what you do is, I'm going to go now to my equation for first moment of area. You see, I know my R, I know my dA. Do we all see that? So for me, okay, so look at it, guys. I'm leaving it there for a bit of some few seconds for you to internalize it, to try and get it in. Maybe I'm hoping. Yes, Sabelo.
Can you please go to the previous slide? I want to see how you made x subject of the formula.
Oh, I didn't show the working. But what you do, you see, it's 49 over 16. It goes this side here. It will become 16 over 49. it will be 49 over 16. Okay, remember it was 16 over 49 here. If it goes
Yes.
there, it's 49 over 16 times what? Times y is equals to x squared. And then after that, you take square root both sides. See,
Okay, sir. Thank
so this 49, it comes to the top here. And this 16, it goes to the bottom then.
Yes.
Okay. So I didn't show that working, but thanks for that question, Sabelo. So that's what we do. So now we know we have our x. See, we now have our r and our x, meaning we also have our dA. So what we do from here, guys, I'm sure by now you know from the first example, we are going to now calculate our first moment of area like this. Our r is 6 minus y, our dA is 7 over 2 y to the power half. So this is what we get. I can take out the 7 over 2 outside. Question, Sabelo? Or is it?
Sir?
Okay, Trichat,
Just a
yes?
minute on your previous. Just a minute on your previous slide.
Okay, sorry. There you go.
Okay, thanks.
Okay. So this is what we have. You see, I now know what is my R, what is my dA. Remember, your dA is always in terms of what? Of y, right? All your things should be in terms of y. My R is in terms of y. My dA is also in terms of y. There's a y to the power half dy. It should be in terms of y because everything we're doing is in terms of y. Okay, so if I go now to here, there you go. Now, what do you think we're going to do next year? This y to the power half, we remove the brackets, straightforward and simple. It multiplies this 6, it also multiplies this y here. So before you integrate, you have to remove the brackets, simplify first. Okay, we're going to do that in the next slide. Also, just a reminder, our limits are 0 to 4, not 0 to 6. Okay, so your limits they only go up to your top of your shape. So it's 0 to 4. Please remember that. Okay. So from here, guys, I told you we remove the brackets. This is what we get. Then we integrate that, we get that. And then we substitute, then we get our answer. Okay, so this is first moment of area. Okay, again, I apologize for them. I apologize. I apologize for the delay, right? For us going overboard. We're finishing up just now. So this is first moment of area. Now, second moment, same thing. Okay. That is r squared. So you need to square that 6 minus y. You square that first. After you square it, you multiply y to the power half inside. Okay, please, it's important. You can't multiply y to the power half before you square. So you have to square 6 minus y, you expand it, and then multiply y to the power half. And then from there, guys, you know what we do? We integrate. After we integrate, we get our answer for second moment of area. When we get our answer, to find the final answer for the depth is second moment divide first moment. Okay, so we have about 5 minutes. 5 minutes to 11, so about 5 minutes left. So let me just complete, right? When you finish integrating, you get your answer for second moment. And then from there, to find your depth of center, just going to do it quickly, right? Because of time. There you go. So that's our answer there. Okay, just a key to let you know about, just know that you're in the right direction, right? Your answer has to be between 0 and 4. It has to be between, it should be somewhere inside your shape. Okay, you can't get an answer which is more than 4. Okay, because they're looking for depth of center. It has to be within 0 and 4, within your height, 0 to 4. So if you see yourself getting an answer like more than 4 for this example, then there's a mistake. Doesn't mean if it's less than 4, it's definitely 100% correct. Maybe if you get something like 2.4, it's wrong, but I'm just saying it's a hint. Okay, guys, we're done. Now, this third one is for a rectangle. Okay, so we're going to do that next week. Okay, but if you want, you can look at it. Just have a look at it as I'm rounding up. Copy it down, do it as homework. Okay, and try other questions. We've done most past papers, they have trapezium and parabola, like I told you at the beginning. Okay, rectangular doesn't come a lot. If you want, you can give it a try, but we'll do it on Friday. And after we'll do it quickly, it won't even take time. After we do the rectangular, I want to do the problem that, what's his name? I think it's Sabelo or someone gave me that problem, right? November 2012. I'm going to do that problem for all of us to see here. Okay. After we've done this example 3, I know we'll finish we'll do it in about 10-15 minutes time. Then I'll do that problem. Then if there's any other problem that anyone has on Friday, you can ask as well. We'll do them. To mean that maybe module 6, I'll start on other Monday. This Friday, we'll finish this module, and I'll do some bit of questions linked to the national test, the test 1. And then next week, I'll start on the last module. Okay, so I'm done, guys. If there's any questions you want before I finish up, you can ask.